Good day everyone, welcome back to the Numberland. Today we are diving into the exciting world of physics to explore momentum and impulse and turning effects, also known as moments. These concepts are everywhere, whether you are kicking a soccer ball, driving a car, or even opening a door. So buckle up, grab your notepad and let's get started. Let's kick things off with momentum. Momentum is all about how hard it is to stop a moving object. It depends on two things, the object's mass and its velocity. The formula is simple, P is equal to mv. Momentum denoted by P equals mass m times velocity v. The unit is kg meter per second. For example, look at in the diagram, a heavy truck moving slowly can have the same momentum as a small car moving super fast. Momentum is conserved in a closed system where no external forces act. This is called the law of conservation of momentum. Think of two ice skaters pushing off each other. They move in opposite direction but their total momentum stays the same. Look at in the diagram. Two ice skaters pushing apart with arrows showing momentum, vectors adding to 0. Okay, now let's talk about impulse. Impulse is what changes an object's momentum. It happens when a force acts on an object for a certain amount of time. The formula for impulse is J is equal to F into T. Impulse J equal force F times the time duration delta T. Cool thing. Impulse is equal to the change in momentum. This is why airbags in car works. They increase the time of impact during a crash, reducing the force on your body. Okay, now let's try an example. Look at in the diagram. Imagine a 0.5 kg soccer ball moving at 10 meter per second. Its momentum is 0. 50 into 10, it's equal to 5 kg meter per second. If you kick it with a force of 50 Newton for 0.1 seconds, the impulse is 50 into 0.15 Newton second, which changes the ball's momentum by 5 kg meter per second. Look at in the diagram. I am showing step by step with the soccer ball being kicked. So momentum keeps things moving and impulse changing that motion. Got it? Let's move on something that makes things turn. Now let's explore moments or the turning effects of the forces. A moment is what makes things rotate, like when you push a door or use a wrench. The moment of a force is calculated as m is equal to force into perpendicular. On the screen, moment m equals the force F times the perpendicular distance d from the pivot point, measured in Newton meter. The pivot is the point around which rotation happens, like the hinge of a door. Look at the screen showing the examples. A door with a force applied at different distances from the hinge, showing larger movement with greater distance. Here is a pro tip. The further you apply the force from the pivot, the easier it is to turn something. That's why door handles are far from the hinge. The wrenches have long handles on the screen. Now for rotation to balance. Like on a seesaw, the moments on both sides of the pivot must be equal. This is called the principle of moments. If the clockwise moments equal the counterclockwise moments, the object does not rotate. Look at on the screen. Two people of different weights balancing by adjusting their distances from the pivot. Let's do a quick example. Imagine a seesaw with a 40 kg kid sitting 2 meters from the pivot on one side. The moment is 784 Newton meter. To balance it, a 50 kg kid in the other side needs a moment of 784. which means distance is 1.6 meter, they balance. Got it? So there you have it. Momentum tells us how objects keep moving, impulse changes that motion, and movements make things turns. These concepts are the backbone of physics in action, from sports to engineering. Next time you kick a ball or open a door, you will know the science behind it. That is, speed is equal to mv, j is equal to f into delta t, and m is equal to f into d. If you love this, smash that like button, subscribe, and let me know in the comments what physics topic you want next. Until then, keep exploring the universe, and I will see you in the next video. Take care. Goodbye.